Alright, boys, so this is gonna be a short stream, okay? Let's set the record straight, okay? So, let me just set the context. Don't ask me why I got the glasses on because my eyes are red, obviously. Why? Because I got a little flu. But today we're gonna talk about architecture. We're gonna try to build an architecture for the website that I'm building, not even just a website, it's actually a SaaS project that I'm trying to build in the backend. In the previous video, I showed you guys architecture for Filter Wave, which is an application for uploading bits direct to YouTube, audio with a still image, and then going direct to YouTube. I showed you already, so I'm not gonna go into it today again. But that was another SaaS project, and today we're gonna talk about a different project. So yeah, let's get straight into it. Let me just show you guys. So I'm just before I do anything here on the architecture, I'm gonna show you guys a project real quick. So yeah, let me just show you the project. I'm just gonna have to run. Let me say I need like 2 terminals. Okay. Yeah. So first we're gonna cd inside the server. This can be for the client. Let's cd inside the client here. Cd inside the server. All right. So these two, the first one is running npm run dev. That is for the front end, and then the second one is running. I think we're using Bun. So let's just say Bun dev. All right. So we have that, and we're just gonna have to cd server one more time so I can run Docker. Okay, let's say Docker compose up in detach mode. I don't know if we have. Yeah, it's pulling the image because I had deleted it earlier. Yeah, I'm stupid. Okay, and next time I won't. I will just take it down rather than delete it. So all right, nonetheless everything is working, so let's just make sure everything works. So I'm just gonna open the application real quick. That is Dirtybucket. Oh my god, let it load real quick. Okay, cool. So as you guys can see, it's a Dirtybucket. This sell your beats, build your catalog. So yeah, that's an application for selling beats. If you're a music producer, you'll understand. Yeah, so that's just the actual application. So as you can see, this is a landing page for the application. Don't mind this or this repeated stuff. Don't mind it because I'm still working on the landing page. But I just want to show you guys like the entire architecture that I'm planning to implement before I do anything. Okay, and then we're gonna have a little discussion about microservices versus monolith architectures. Okay, so let's get straight into it. As you can see, we have like cool chassis and things going on here. So let's say a user clicks get started. So once they log in here, they can say get started, but you can even just continue right here. And then let's say this is how the user will just get to application. We obviously the dark mode or light mode, don't forget it. So let's say the user gets to our website and then they hit get started, then they are, you get it, you have to pay before you use the application. I'm joking, but there's a free version for you to test the application, and then we just have only 2 tiers: free tier and pro tier. That's what I want to improvise. So the one for the free tier is like the users will just upload only 5 bits and that's it. After they upload 5 bits, we kick them out of the platform unless they pay. So if you want to continue using it, you gotta pay, my brother. So yeah, let's say they want to test it out. So get started, and then this one is unlimited, obviously. So as you can see, if they choose the yearly, they can get a discount of 20%, and then it reduces the price monthly. So yeah, it is what it is. So let's just click get started, and we're just gonna continue with Google for now, so we can just make it easy. Let's just select any of these. Don't worry, I have so many emails here because some are just for test emails, some are just all right, so now once they're logged in, we say welcome to Dirtybucket. What best describes you? So from here, a producer can choose to be a producer, an artist can choose to be to just browse the beats. Okay, because obviously we don't want to have artist profile. I just don't want to. I want to reduce the overhead. So we're just gonna go to like continue to your profile, because the producer is the one that has like the most impact. The artist will just browse the beats and then add the beats to their card. I'll explain that when we get to the architecture part. So let me just continue here so I can show you guys what I'm trying to do. All right, so here you can see we have logout. This is like, okay, here we can build a dashboard and all that. All right, that is not going to be our issue for now. So yeah, we're not going to log them out. I think I'm just going to log them out because I just wanted to show you guys what's going on so far with the application. So let's just go to the home page. Let's go back to the home page, and then we can go to the architectural side, and I can show you guys everything that we're gonna need for this application. So yeah, contrary to Filthy Wave, if you didn't watch that video, I'll just tag it somewhere. I'll put it like, I don't know, this side or this side. You guys will get to see. So yeah, I'm just gonna take it down right now, so we can get to the architectural part. And I'm going to explain the architectural part in a very simple, concise way for you to understand. I'm not here to teach you architecture. You can go and learn it on your own, but I'm just going to go on the high level part of it. So let me just say Docker Compose down. Let me take down the Docker Compose. Okay, so there you go. If we check our containers, you see we have no container running because we took it down. So that is it. Now let's get to the architectural part. I'm just going to come here and delete this. So first, before I continue with the Dirtybucket architecture, let me see if I can go back here. All right, I can just go to Filter Wave and just get some inspiration, but we're going to build it together. All right, we're going to build the architecture together for just the application that I showed you. So this is the architecture that we used in the previous video. I haven't yet implemented 90% of the things because this is a simple application actually. As you can see, there's like a lot going on, but it's not really a lot. Yeah, a lot going on, but it's not a lot. But you get the point. So let's get to, hold on, just give me a sec. Okay, let's get to the data bucket architecture. So let me start with the the high level of things from the tech stack. Let's just go ahead and just where is it? Can I just type here? Okay, cool. I can type. So I'm just gonna say tech stack. Now for this tech stack, I want to design it with you guys because the previous video, the entire architecture was already designed by me, and then I just went to explain it. But I'm just gonna design this one with you guys together. So let's just go ahead and do it. All right, now we're gonna start with the architecture. With the tech stack is I don't know if I'm not mistaken, it's just the same thing. Let me just go back to filter wave here. The architecture is somewhat the same, okay? But we're going to have to discuss something about what was I talking about? Oh my god, I kind of forgot. Okay, microservices and monolith architecture. So let's just grab this, and that's gonna be it. So let's just go back here, and I'm gonna show you guys what we're gonna need. So let's go back to filter wave to Dirtybucket. Yeah, it's hard to use this application here, bro. So let me just drop this, and let me just zoom out a little bit, just like this. So this is going to be our main tech stack. All right, let's say tech stack. Oh my god, tech stack. Can't even type, bro. Okay, that is our main tech stack. For the front end, obviously Next.js, CN, and how do I call it? This is like, I mean, Next.js, Tailwind, and CN. But we're gonna add a little bit of somewhere here for the auth. We're just gonna use, obviously we are using better auth already. That's the one I just explained to you guys in a sec. So we have better auth. I don't know if I should just reduce it, something like that. All right, I'm just gonna reduce better auth here, and I'm just gonna put it somewhere here. And let me just extend this to the side. All right, I'm just gonna put a little circle here around better auth. So yeah, so these are the tech stack that we're gonna use. We're gonna use better auth for the authentication, obviously, and then Next.js. You know why we need it, because Next.js has the app router, which is the best. You can compare it to no goddamn React. Just okay, it's built on top of React, but you get the point. So it has SSR, SSG, which is static side generation, and server side rendering. And of recent, I had something about uh, I don't know if it's pre-rendered something like that, something like that. So you guys can check the documentation, but yeah, you guys get the point. If you understand, then you understand. So let's get to the backend side of things. We have this front end. Let me just grab this and put it right here. So we obviously, the first thing you got to do is always start with your backend, to design your backend first before you get to the front end. But don't be like me, because for me, I tend to always just get the front end, not like the entire workflow of the front end, but I always want to get the overview of things, like how they look on the front end, and then just attach them with my backend. But you can work with them in parallel, like a little bit of backend, a little bit of front end. So we're just gonna do the architecture first. So let's start with the backend. Now, as you can see, we are using Bun obviously as a runtime to just replace Node.js for us. It's not it's not like a solid thing to use if you want to, like, use like all dependencies, or like, because Bun is still new, right? So there are so many dependencies that are not very compatible with Bun, but it depends on you, my brother. If you want to use, just use it. So I'm going to use Bun as my runtime. And obviously, Bun comes with TypeScript. I don't even know why I added TypeScript, but it's okay. Bun comes pre-installed with TypeScript. It comes pre-installed with its own testing. I think I would say testing framework. Like it's like Jest. If you use Jest for testing, Bun comes with one already pre-installed. Then we have Express, which is going to be for creating our API endpoints. Obviously, it's just like it's just a framework of Node, but we're using Bun, so you get the point. And we're using Prisma as the ORM, which is the object relational mapper, which just talks to our database, PostgreSQL. So you guys get the point. I'm not going to explain much about that. And AWS, as I showed you guys in the previous video, it's just S3 bucket. So let me just grab this. Let me just grab this and let me we can actually just add it from here. Just say S3 bucket, something like that. And yeah, this is just going to show S3 bucket. So we're just gonna add it something like that. And obviously Docker and Redis and PostgreSQL. Now I'm not gonna go so much on Redis for now because I haven't yet thought so much about where I'm going to need Redis. Obviously, you need Redis, but I haven't put it in like you know. But we're gonna leave it just for like for the convenience. Okay. All right. So as you can see, we have the tech stack in place. Now the next thing we gotta do is think about how everything will flow. Okay. But before I go to how everything will flow, I have two sets of architectures I want you to know. Okay. Not like I want you to know. You already know, anyways. So the first one is the simplest one, which is a monolith architecture. From the name mono, you can tell mono means one, right? So that means inside we shall have a big application, and most people know, I think, only monolith architecture. I don't know if you already know, you know, what I'm going to talk about, but most people just know monolith architecture. So what is monolith architecture? Let's just get it straight into it. Let me say monolith. Oh my god. Oh, what? Damn. Okay. Architecture. Oh my god, can't even. That's my biggest challenge, boys. I can't even type faster. I think I type like your grandma. All right, bro. So we have the monolith architecture, and what are we going to need in a monolith architecture? We're gonna have the front end here, front end, and then we're going to have the back end, and we're gonna have the database. Okay, let's just grab this just for the symbol of database. No, not that, but we can just go here and say database. I think database, something like that. Okay, so as you can see, we have a monolith architecture. So that means everything happens inside one big application. Okay, we're having a big application where we're having the front end, the back end, and the database. All of them under one umbrella. That is a monolith architecture. And that's what I'm planning to use for the MVP. But once we get traffic and we get like users, let's say we get like a million, not a million, a million is a lot. Let's say we get like 100, let's just say 10,000 users. Now, if your API is only designed or architected, is that a correct word to use? Architected to use for only like limited users, let's say for it just accommodates 10 users. Now all of a sudden when you just get a surge, like let's say your application goes crazy or it blows up on anything and then people get to it, all of a sudden you have like 1 million users spamming your API endpoints. Your application will crash if you don't know how to scale it. So now scaling a monolith architecture is a pain in the, you get what I'm saying? So we're going to go and divert to something like let me put this here, and we're going to go to microservices. Now I'm not going to go straight into microservices because the reason being microservices are like they are hard to maintain and hard to spin up, and it's like it creates a very big overhead, right? It creates a very big overhead to the point where you don't get to create what you want to create. So if you have an MVP or you're a startup or anything, you don't need microservices. Okay, just start with a monolith. Once you get users, then you can just, you can transition to microservices, but we got to discuss it nonetheless. So let's go and discuss that. All right. Now, It's hard in here, bro. God damn it. Hmm. Anyways, let's go to more microservices. So for the microservices, we're going to have, let's say, a client, which is going to be this, and then we're going to need another service. Let's say, like for example, for the bit thing that I'm trying to create, for the application that I'm trying to create, I'm going to need a. Let me just explain it with like a simple order and purchase and stuff. Let's say we're building an e-commerce website, okay? So we're going to make it simple like this. This is going to be our front end, which is going to be our client. So I'm just going to go here, change this back to text. All right, I'm just going to say client. So let's say we have client. And by the way, I'm also teaching you guys how to use this cursor. This eraser. All right, so boom, as you can see, we have the client. Now, let's say this is a different service. Let me just call this, let's say order service. I'm just going to say order service. All right. So microservices, that means you just decouple your entire application. You just decouple your entire application, and then let me just take this. Just give me a sec. Take this. All right, you decouple your entire application and then separate like everything into different services. All right, payment service. All right, this should do it for payment service. And here we're going to have another thing. Let's say notification service. Okay, let's say you want to send notifications to the users like via email and all that stuff. So let's just call this notification service. So each service is going to have its own database. Let's go to the database. Let's pick a database. All right, so as you can see, each service has its own database, so we are not really dependent, or we are not coupled to one database. We're not sharing one database. You can also have an architecture that's going to share the database, but it depends on you. So each service is going to have its own database, as you can see. And after that, we're going to communicate with the client via an API gateway. It depends on you, though. You can decide to communicate directly with the different services, but it's just going to take you, it's going to take a toll on your application. Let me just select this one and just bring them down a little bit. All right, so we're gonna have something like this, and let me just extend this. All right, let me take this here. Now we're going to have something like this. Okay, we're going to have this as the API gateway. Let me just bring this here, and I'm just gonna call this API then gateway. Okay, something like that. It's gateway, bro. API gateway, something like that. All right. I think you guys get the point. So we have API gateway, and these are the different services. Now, another thing is we're going to have intercommunication between these services. You can decide to communicate directly with every service via asynchronous messages. Asynchronous methods like using REST APIs, which is like the get, the post, the delete, the update. You get a point. So you just create an endpoint, REST endpoint, and communicate via these ones. You can also use gRPC, which is Google something something something. Do your research on that. So it's gRPC. You can also communicate with gRPC. But for now, we're just going to use something called event-driven architecture, which is also microservices, but we're going to need to create an event. So the events will be consumed. We're going to have producers of events and consumers of events. So the producers of events will be, I'll show you in a sec. So let's go ahead and call this. Let's say we are going to use, you can use message brokers. I think you guys know who a broker is, like broker for houses, right? But we have broker also in while coding. You get what I'm saying? So we're gonna have a broker. As you can see, this is a broker. Kafka as a broker or a message broker. So what Kafka does, it will share information, right? And it will just create, it will receive events and deliver events. That's just basically it. So let's say from the order service, like a user places an order from the front end here, okay, to the API gateway. Then the API gateway can now distribute, right? But let me not add a layer of complexity here. So for now, let's just forget about the API gateway. Just leave it there. Know that the API gateway is there. But let's go to how everything will happen. So we're going to need Kafka here. Now the order service will produce an order event. All right. We shall produce an order event and send it to Kafka. And then we shall also get this, boom, You see that? We shall create an order event and then consume an order stuff from here. Okay, this is the order service is creating an order event and then it's sending it to Kafka. And we're also going to create this and hold on, this is not going to come back here. The order service will, if let's say we place an order, we send it to Kafka and then Kafka will we shall consume the order event that was created from here inside the Kafka directly by the payment. Okay, let's say the payment consumes this. Boom. Payment service will consume the order service that was given here. It will check, hey, people just placed the order. Okay, now Kafka will deliver the message to the payment service like, okay, cool, the order has been placed. Now you should go ahead and also create the payment. So inside the payment service here, where we're going to have Stripe, you can have like how do I call it? You can have Stripe, you can have Lemon Squeezy, you can have other applications that you want to use for the payment service. You can even use different languages here, like literally in different services. You can say the payment service you want to use Java. For order service, you want to use JavaScript. For notification service, you want to use Python. It depends on you. So that's the flexibility that microservices gives you. Now we can go ahead and say, okay, cool. The order service, we create the order. We create the order service, we consume it inside the payment service, and then we also create a payment or payment event, right? And then we consume it inside the notification. So this notification here is going to consume this. Just give it a sec. It's going to consume this payment service, payment event, right? And we are going to inform, and then we can save it in a database. Okay, all these services will always save things to the database. Let me just extend the database a little bit here. Okay, all these ones will serve to their own databases, so there's nothing at all that is like coupled together. So we are creating something called decoupling our entire thing. Okay, now boom, we're saving to the database. Okay, we create an event, we save to the database, create an event, save to the database, just like that. So you get the point. All right, now we're going to have here within Kafka, we're going to have consumers and producers. So consumers will be the services that will consume the events that were created by a producer. So that is going to be complex for this video. I just want to make it simple for you to get a point. Now there we can just get the entire thing here and just share it with the API gateway. Then the API gateway can return the response back to the client. And as you can see, this entire communication here is real time. There is nothing here that is that is going to take time. This is real time. Anything that you see, the moment the order service is created, payment service also gets to work. And at the same time, order service is just going to be free to receive another event again. To receive another event again from the front end. You get what I'm saying? So just like that. But yeah, I might not be the best at demonstrating, but that is it. I've done my best, my boys. So that's going to be it for that. And I'm not going to go direct into using this architecture, microservice architecture for now. So I'm just going to stick with my naive, I'm going to stick to my naive front-end, back-end thing, okay, for now. But once we get some good users and we expand, then we can go ahead and use this architecture, which is microservices. And that is the architecture that is used by 99% of the big tech companies. 99%, I think 100%. I don't know any big tech company that uses Monolith anymore. People used to use it like back in 2010, but currently it's just for startups and people who are just starting out and stuff. But if you want to like learn also, you can go ahead and learn and start using microservices. But it's funny how somebody would build it to do up with microservices. All right, so we're gonna have that, and we're gonna have our database just right here. All right, so this is the architecture that we're going to go with, and that is the most common architecture most people know. All right, my boys. So I'm just going to call this database. Okay, I'm so slow at typing. Okay, excuse me on that. All right, so let's say we start with we use our monolith architecture. So how are we going to do everything? So how we're going to do everything is a user, which is a client, which is going to come here, and let's say user. It's always good to like break down your entire thing and plan out your application so that at least you don't get stuck somewhere. Okay, so let's say this is the user. What a user is going to be able to do in our application, I'm just going to make it simple. A user will just interact with the application. Let's say in terms of the application we're building, it is Dirtybucket. Obviously, a user will log in and then boom, use our application. So we're just gonna say this should be an authenticated user. Let's just say this is gonna be auth user, and we are going to use better auth for that. Um, I'm gonna tell you why. I mean, how everything is gonna come together. Okay, so that's better auth. As you can see from this entire architecture, I mean this tech stack, we're going to explain how we're going to use everything. So obviously with Next.js, I already explained, and I don't want to tell you why I'm going to use Next.js over React. Anybody who has a brain knows why I'm going to use Next.js over React. So that's it. The next thing is now for the backend, I'm just gonna go straight into backend. I'm not gonna explain the front end, but I can make it easy for you. So a user is gonna be able to log in into our application, and then a logged in user will, like I showed you guys how the entire flow will be. You will get logged in, and after logging in, you will now use our application. But before using our application, you'll be redirected to first choose a tier. Okay, but most people want to try the application, so they're going to try the free tier anyways. So they try the free tier, then they already logged in. We store uh, their their credentials in our database, which is PostgreSDB, and that everything is handled by Bro. We're not going to handle anything about the authentication. You can also create your own authentication, but why create a new one when there's already one working? So yeah, all right. Now that is it. A user is going to be able to do that, and then after that, they will create a profile, and then you can separate concerns. You can create a artist profile and a producer profile. And the producer is going to be able to create a beat, right? So a producer can log in and create a beat, and once they create a beat, it's going to be a post request to our backend. Now, what's going to be happening in our backend is like this. So let me just explain it with this stuff that is here. So a user is going to come here, and then from Next.js here, which is our front end. So the user will be able to create a beat, post request to create a beat. Now that create the beat post request thing will be handled by our express here. You get it will be handled by our express, and then the beat will be sent direct to our S3 bucket, which is this AWS S3 bucket. All right, and then from there it will give us URLs, right? It will give us URLs for like the audio, the image, and then metadata for metadata will not be stored here. We're only storing the images and what and audio, and then we shall extract the URLs from the image and the audio, and then distribute them using CDNs. And this is where also Redis will come in between, okay, to help us. So after the Redis coming, like let's say we fetch once, right, the image and the audio from our S3 bucket, and then store the URLs inside our database, which is our Postgres database. After we store them, let's say the user requests for the same exact data again. So rather than hitting our backend again, and then also hitting our S3 bucket again to get the request, right, to get the information that we have in our S3 bucket, at the same time our database as well, that is just going to be like it's going to be expensive. You get, imagine if you have like 10,000 people doing that thing, you're gonna rack up a bunch of credits. Like you're gonna owe people a lot of money, especially AWS. You get, so yeah, that's expensive. That's where Redis will come in. So Redis will come in to cache, at least it will cache the data that's already requested, so that we don't have to hit the database and we don't have to hit the S3 bucket again. So we can have Redis that will stand between our request with S3 bucket, and also Redis to stand between our database and our backend. So you get the information, and everything is Dockerized. Everything is running on Docker. That's the thing that we're going to do. Okay, so let me just explain it with the writing, so you guys get the visuals ready. So let me go ahead and try to explain it. All right, so let's break down the backend real quick. Okay, so the backend is going to look like this. We're going to have first backend is going to be here. Let me just write here a strip bucket one more time. So we're going to have a S3 bucket just here. Let's say we have our S3 here, and we're going to have Postgres here, okay, which is our database. So we're going to have our Postgres here, which is our database. So this was going to happen. Now we're going to need, oh my God, why tripping? So we're going to have this just here. Okay, cool. So we're gonna have our backend like this, and then our front end will place will ask or will request using a post request endpoint, right, to create a beat. Now here's the thing, like I said, it's almost the same as what we have in the filthy thing, because we are going to need something called let me just go back here. We're going to need almost the same architecture, but we are not going to use some of the things, okay? We're going to need almost, yeah, bro. Excuse me. This is more organized because I took my time, but the one for explaining is just a little bit disorganized. So you get the point. So yeah, we're going to create pre-signed URLs and all that stuff, all that good stuff. We're going to create that, but I just want to make it easier for you to understand. Okay, so let's go back here, and our front end will make a post request to our to our backend with our audio, with our URL, I mean our audio and image, and then price, metadata like price, the BPM, which is beat per minute as far as beat is concerned. We're also going to keep track of the license. We're going to keep track of what kind of beat is it? Is it like a custom beat? Is it a basic license? Is it which is a basic list, or is it an exclusive list, or is it an unlimited list? So that one we shall have to like create licenses for every kind of beat that is bought. If you're a music producer, you know what I'm talking about. So yeah, after that metadata is attached to our post request from our front end, right? Then boom, the beat is going to be stored in our database, which is the metadata, which is the name, the title, the description, everything that I just spoke about. And then also from the same post request, we are going to also store the actual images themselves inside our S3 bucket, right? S3 bucket is just going to take only the audio. So let me just go here and say audio. S3 bucket will take audio and the images, okay? Because now the reason why we might need images, if you guys go to like let's say Apple Music or even Spotify, not even Apple Music, let's just click Spotify. As you can see, I was listening to this. If this is your favorite song too, big ups. So as you can see, every single song has an image and has a title, has the artist and all that. And if you play, obviously there's audio. So it is close to that, but it's not the exact thing that we're building. We're not building a Spotify, but yeah, we're gonna need the image and the audio, right? Then the actual image and the audio themselves, they're gonna be stored inside S3 bucket. You don't want to store audio files in your database, bro. That would be crazy. So they are going to produce URLs, and these URLs are going to be consumed or stored inside our database. Okay. So what is going to be stored is just the URLs. Now the URLs will be the ones stored inside our database. URL plus metadata. Okay. Let me just go here. URL plus metadata. But we don't want to attack. I don't want to confuse it. So the audio and the images will produce URLs that will be sent to our database to store them as URLs, so that when we click that URL, it will be previewed to us. We shall see the actual song or the actual beat. And just give me a sec. Oh my god, I got flu, bro. You guys can tell from my voice. I'm sorry. Anyways, so our S3 bucket will produce URLs and the URLs will be stored there. But the URLs, all that S3 bucket, how we're going to produce the pre-signed URLs, how we're going to produce everything, how we're going to store everything in S3 bucket. If you want me to explain that design, yeah, can tell me in the comment section. I'll make a video about it. So that is it. URLs gonna be there in the database, and then what is going to be also coming from this front end as well from this post request. This post request will have oh my god, what's that? All right, this post request from the front end will come with let's say metadata. Oh my god, metadata will come with metadata plus audio and image. Okay, all right. So this is what will be coming from our post request, right? Will be coming inside the post request and then sent to the backend. This is the backend. Let's just say backend. All right. So this is the entire thing. It's simple actually to understand from like the high level point of view. All right, so the metadata and the audio will come direct to our backend, and then from here, this is where our backend is just going to distribute them. Okay, say, hey, oh, inside this request has we have the audio and we have the image. Okay, take the image and the audio direct to S3 bucket, and get the URLs and store them in the database. That part of S3 is done. Okay, and then our database here is going to store the URLs and the metadata. Okay, so let's come here and say, okay, cool. What you are taking from here, you're taking metadata. Okay, metadata, metadata, and what is common here, like I said, is audio and image. That is what is here in the S3 bucket. So now, how is our front end going to receive whatever that we have here? We're going to use Redis, okay, to cache the data. So let's just go here and say Redis. All right, cool. Let's select this. So we are going to, in between these ones, we'll have Redis. Let me just put it here for the responses. Let's go back here and say what we are going to pick from here will be first going through the cache. Okay, after they go the first time, they are not going to be cached. Okay, we shall cache them and then check, hey, next time if we want to request the same data, is it there in the cache? I mean, is it there in our Redis? If it's there, okay, cool, they use the one in the Redis. If it's not there in Redis, then just create it, and then you guys get the point. So we're also going to need to cache this as well. This one. So there's cache here between S3 bucket and this, and also there's cache between the the uh the S3 bucket and our backend. So that should be it for the entire thing. If you guys have questions, yeah, let me know. Right now, I've been started a lot because I don't plan nothing. Like I just speak off the top of my mind, right? Yeah, that's a skill to have. But it is what it is. So that is just going to be it. So users are going to, the main thing, the main entire application will just be creating beats, updating beats, deleting beats, selling beats to users as well. So here as well, we're going to also have payment services, like we're going to also have payment included in the backend here, and we're going to use, let's say, Stripe. Let me just say Stripe here. We could use Stripe, but we're not going to need a Stripe for now. So we can say Stripe here, and then we're going to also talk to Stripe to create payments, right? You get it. To create payments, and that's going to be it, really. That's going to be it, like, actually. So that's about it, bro. And I think I've explained every single thing here, except we didn't add Stripe here, backend, but you guys get the point. So yeah, that's gonna be it, man. I've talked a lot. So see you guys when I upload the next video, bro. So much love. See y'all tomorrow. Okay, y'all should subscribe if you want, though. If you don't want, it's all good. Okay, we are close to 900 subscribers in 3 months. That's crazy work. Anyways, thank you guys, bro. See you guys tomorrow. Let's go.